Hello everybody. Today we will be learning continuous random variables and a normal distribution and also a standard normal distribution and how to solve basic problems using this. So let's get started. A random variable is called a continuous random variable if it can assume infinite number of values in an interval. So if x is a random variable and y equal to fx, so this fx is called the probability density function of x if these conditions are satisfied. What are the conditions? First condition, fx greater than or equal to 0, integral minus infinity to infinity fx dx equal to 1, and probability that x lies between a and b is integral a to b fx dx. And the normal probability distribution is an example of a continuous probability distribution. So if you have a normal probability distribution, it will be a bell-shaped curve. This is the mean, which is equal to mode equal to median. It never crosses the x-axis and extends indefinitely on the right and left side. The total area under the normal curve is 1. And the probability density function for a normal distribution is given by this. That is fx equal to 1 by sigma root 2 pi e raised to minus half x minus mu by sigma the whole squared, where x lies between minus infinity to infinity. Now mu and sigma are the mean and standard deviation of the normal distribution. So if I say probability that x lies between a and b, this is the area under the normal curve bounded by the ordinates x equal to a and x equal to b. A random variable that has a normal distribution with mean mu equal to 0 and standard deviation sigma equal to 1 is said to have a standard normal probability distribution. So note that for a standard normal probability distribution, mu is 0, sigma is 1. The probability density function for a standard normal variable z is given by this, fz equal to 1 by root 2 pi e raised to minus z squared by 2, where z lies between minus infinity to infinity. So area under a standard normal curve is given by probability that capital Z less than z. This is fz. So what is fz? Probability that your value capital Z is less than z, and this is integral minus infinity to infinity 1 by root 2 pi e raised to minus z squared by 2 dz. So if you draw it, it will basically be this shaded curve, area to the left of z. If I say probability that z lies between z1 and z2, that is f of z2 minus f of z1. So under the normal curve, it will be this shaded region between z1 and z2. If I say probability that capital Z less than greater than z, this will be 1 minus probability that capital Z less than or equal to z, that is 1 minus fz. So again under the graph, it will be this region shaded on the right. Now certain properties to remember. F infinity is 1 by root 2 pi e raised to minus infinity to infinity e raised to minus z squared by 2 dz, and this is 1. And f0 is 1 by root 2 pi integral minus infinity to 0 e raised to minus z squared by 2 dz, and this is 0.5. So remember, the upper limit changes. F infinity is 1, f0 is 0.5. Now f0 represents half the area under the curve. And again, f minus z is 1 minus fz, that is the region on the left or the right. To find the area under any normal curve, first convert the normal distribution to the standard normal distribution using the formula z equal to x minus mu by sigma. Then we use the standard normal table to find the values. So just points to remember. Probability that capital X less than A is same as probability that capital X is less than or equal to A. Probability that capital X greater than B is same as probability that capital X greater than or equal to B. And probability that X lies between A and B is same as probability that A less than or equal to X less than B is same as probability that A less than X less than or equal to B is same as probability that A less than or equal to X less than or equal to B. So what are we trying to say? That whether you have less than or equal to or greater than or equal to, the values are all the same. Now we have the normal distribution table. I have not taken a printout of that in this video, but you can go online and check any normal distribution table and see how to solve problems. So we start with a few problem solving. X is a standard normal variable. Find probability that Z less than 1.9. That is same as F1.9. So F1.9, if you look at the table, it is 0.9713. Again, probability that Z greater than 2.7. We had seen that this is 1 minus probability that Z less than or equal to 2.7, which is 1 minus F2.7. F2.7 using the table will be 0.9965. So you will get the answer as 0.0035. The next question, probability that Z lies between 0 and 1.45. This will be F1.45 minus F0 as we have seen earlier. Again, using the normal distribution table, you get F1.45 as 0.9265. F0 we have already seen as 0.5, so this will be 0.4265. What about probability that Z greater than minus 0.57? This is 1 minus probability that Z less than or equal to minus 0.57 or 1 minus F minus 0.57. And F minus A is 1 minus FA. So it is 1 minus bracket 1 minus F 0.57. So the 1 cancels and you get F 0.57, which is 0.7157 using the normal distribution table. Coming to the next question, probability that Z lies between minus 1.3 and 2.4. So this will be F 2.4 minus F minus 1.3. That is F 2.4, F minus 1.3 is 1 minus F 1.3. So when you open the bracket, you get F 2.4 minus 1 plus F 1.3. Again, using the normal distribution table, F 2.4 is 0.9918 minus 1 plus F 1.3 is 0.9032. So you get the answer as 0.895. The next question is probability that minus 3.01 less than Z less than minus 1.38. So this would be F minus 1.38 minus F minus 3.01. That is 1 minus F 1.38 minus 1 minus F 3.01. So when you open the bracket and use the normal distribution table, you get 1 minus 0.9162 minus 1 minus 0.9987. That will be 0.0825. These are all problems where X is a standard normal variable. Now, what happens if X is not a standard variable? Standard normal variable. If X is just a random variable with mean 12 and standard deviation 3, find the following. So here mu is 12, sigma is 3. So Z is X minus mu by sigma. That will be 15 minus 12 by 3 is 1. So we have converted Z to a standard normal variable. And now we use the same result what we had done earlier. So find probability that X greater than 15. So this would be probability that Z less than 1. Because converting it to a standard normal variable, Z is X minus mu by sigma. And 15 minus 12 by 3 is 1. So this is F of 1. That will be 0.8413. What about probability that X greater than or equal to 18? Again, Z is 18 minus 12 by 3. That is 2. So this will be probability that Z greater than or equal to 2, which is 1 minus probability that Z less than 2. That is 1 minus F2. And using the normal distribution table, this is 0.9772, which is 0.0228. So that concludes this lesson. We have learned what is a continuous random variable, properties of a standard normal distribution and a normal distribution, and how to use the normal distribution table to do simple problem solving. Thank you and stay tuned.